So on homework 15, we're going to do the confidence interval for the population mean. This time we're going to use the t distribution instead of the z distribution because we're not going to know the standard deviation. So, well, we're going to know the sample standard deviation instead of the population standard deviation. It tells us the formula here is we're going to have our sample mean, our x bar, plus or minus. This time we're going to use the t distribution. Same thing, it's going to have that alpha divided by 2, but we're going to have to do all that stuff like we did on the previous one. And then we're going to have the sample standard deviation, which they say is s sub x over the square root of n. So it looks sort of like the other one, only we're using the t instead of the z.
What is below that thing?
It's an x. This one, alpha divided by 2.
By 2.
Yep. Because we're going to have our curve and we're going to have the middle and we have to find the ends. So it says a researcher collected sample data for 9 women. So we know that n is going to be 9, right? Ages 18 to 24. The sample had a mean serum cholesterol level measurement in milligrams per 100 milliliters of 188.6. So my x bar, my mean, is going to be 188.6. My sample standard, whoa, the other video's done. Let me flip that back over here. Now it erased all of my stuff. All right, my sample standard deviation, which is the s sub x instead of having the population standard deviation, this is the sample standard deviation, is 9.7. And we want to find, assuming the serum cholesterol levels for women ages 18 to 24 are normally distributed, find a 99% confidence interval. So again, 99% is the middle. We want to find the end, so when we calculate that number in our formula. So we're going to do the 1 minus 0.99, which is 0.01. We're going to divide it by 2, because we have 2 ends, which gives us 0.005. So this end is 0.005. This end would be 0.005. That's that number that's going to go in for that alpha divided by 2. We just figured that out. So our x bar, our mean value, is our 188.6 plus or minus t sub 0.005 with a degree of freedom of... Does this tell me what my degree of freedom is? Oh, I got to figure out my degree of freedom. I never did that yet. It doesn't tell you what the degree of freedom is. Your degree of freedom is going to be n minus 1. So, I have 9 women. 9 minus 1 is going to be 8. That's what I'm going to use for my degrees of freedom. Whatever n minus 1 is. I didn't leave myself enough writing room. I still have to put the rest of my formula in there. Sample standard deviation was 9.7 divided by the square root of n, so the square root of 9. Smash all of that in there. And then you want to put that in the Alex calculator. And so when you put that in the Alex calculator, what did you get for your lower and your upper limits? 88.6. You got the plus or minus, and then we're going to use the T sub. So that one right there. 0.005. The degree of freedom of 8. Whoops, we're not done yet. Undo that. Now we got to click up behind that, and in parentheses, or 9.7 divided by the square root of 9. Behind there, close your parentheses. Now we can hit equals or enter. All right, and slide to the beginning. Oops. All right, 177.8. It looks like we should round that off too, right? So we got 177.8 to 199.4. That look great. All right. Number 2, they weren't so nice on. Number 2, they're going to give you a list of numbers instead of giving you what the mean and the standard deviation is. So, we used our calculators earlier, way back in probably chapter 4 or 5 when we did this. And we typed in our list, right? You want to use that one there or this one here? Doesn't matter, I guess, which one you use. But remember when we put our list in, we put in stat or press stat. We press number 1 to get to our list. And then we're going to type in our numbers. If there's something in there, if you cursor up, hit clear and then enter, it should clear out all of your numbers. And we got to type in our numbers. 36, 34, 48, 46, 25, 31, 49, 39, 25, 40, 41, 33, and 45. So you did stat and then number 1. Enter your list. Got your list in there? Then once our list is in there, we hit stat again and we went over to calculate. So stat, calc. And we calculated the one variable statistics, so we're going to do number 1. And we want to calculate it on list 1, right?
Mine didn't sort.
Doesn't matter, it doesn't need to be sorted.
Okay.
We just need to calculate the statistics. So we're going to hit stat, and then go over to calculate, and then do number 1. And then just enter through your list.
So you wrote that one now?
So, I don't know if you wrote it wrong or not, but we did stat 1, we entered our numbers in, then stat calculate, and we calculated number 1 again, which was one variable statistics. And so you want to calculate that on list 1. And then you should have your mean and your sample standard deviation on your list.
Mm-hmm.
That's an older calculation, so you have to do second function and list L1, yep? And then enter, yep? Okay, so,
Wait, how do I do this after I get to 1 bar stat?
it should already say list 1 in it, otherwise we just keep entering. All right, so, it tells us there that our mean value, if we look at our statistics, I'm going to write it up here. X bar, our mean is 37. I'm going to just go, how far did I go? 846. That's how far I went. 37.846. You got that number? Yep. No? Maybe? Then we have to have our standard deviation. And so we're using the S of x1. If you look on your list, looks sort of like S of F. And you have 8.061 is where I rounded it off to. 8.061. And we know N is how many numbers were on our list? 13. And that's probably all we need to know for our formula, right? So now we got to put it into our formula. Our formula says we're going to take our x bar, our mean, 37.846, plus or minus t sub, and we got to figure out that number there. So we are doing it to a 90% confidence interval. 90%'s in the middle. That means if I do 1 minus 90%, I'm going to have 10% for my two n's, but I have to divide it by 2, of course. And so I'm going to use 0.05. 0.05. My degrees of freedom. My degree of freedom is n minus 1. Since n is 13, 13 minus 1 is going to be 12. So we're going to use a degree of freedom of 12. Times my sample standard deviation was 8.061 divided by the square root of n. So we have the square root of 13, right? And that is what we're going to plug into our calculator.
And this one.
Yep, well, that one up there. See, this one says carry your intermediate computations to at least 3 decimal places and then round our answer to 1 when we're done. So it did tell us how far to carry out our stuff. I would have read.
Okay, which one am I supposed to have on here?
Which one of what?
This one?
Nope. Let's back that up. Backspace a couple. Okay, so we have the 37.846 plus or minus the t sub. There you go. Then the 0.05 goes in there with a degree of freedom of 12. Click up. And then in parentheses, you're going to have your 8.061 divided by the square root of 13. Click behind there, close your parentheses, and it equals. All right, so to 1 decimal place, our lower limit was 33.9, and our upper limit 41 point
or
8. I believe it should be 41.8. Again, they probably give you a little bit of leeway depending on how far you carry out your intermediate computations. And again, since my mean was 37.8, that should be between my two numbers. If my mean isn't between my lower and my upper limit, I know there's something wrong. So if they give me the list of numbers, instead of just giving me the data, I'm going to type that list of numbers into my calculator and calculate the one variable statistics, because we probably don't want to have to do that big long formula for standard deviation that we did way back in chapter 4. All right, number 3 is one where they gave us our numbers again, so we could practice. So, again, we're going to grab our calculator. We're going to hit stat 1 and clear out our list. So cursor up to L1, hit clear, and then hit enter. And then we're going to type our numbers in. They give us bigger numbers this time. So, 2687, 2622, 2447, 2482, 2677, 2074, 2434, 2256, 2207, 2565, 2151, 2613, and 2613. So once you get your 13 numbers in, you don't have to worry about sorting them. We're just going to hit stat and cursor over to calculate, and we're going to calculate number 1, the one variable statistics. Now, if you're using this older calculator, you have to put the L1 in there. On the new calculator, it's already there for you. And then just go ahead and enter through your statistics. And so then we've got to figure out our X bar is what number to at least 3 decimal places. .308. That's our sample mean. We also need our sample standard deviation. It looks sort of like an S with a sub X. Our sample standard deviation would be 210.626. We know our N. Our N is going to be 13, and while I'm thinking about it, our degree of freedom then is going to be N minus 1. So 13 minus 1 is going to be 12, right? Those should be all the numbers we need to know for our formula, except for we have to do our 99% confidence interval. So if we're doing a 99% confidence interval, we know 99% is in the middle. We're going to do 1 minus 0.99, which is 0.01. We're going to divide that by 2, which gives us 0.005. That's the value we're going to use for alpha divided by 2. So now, plugging those into our formula, what are we going to do on our calculator? We're going to have
2448.308 plus or minus t sub 0 or 0.005 df12 times 210.626 over the square root of 13.
exactly. So our X bar 2,448.308 plus or minus the T sub 0.005 with the degree of freedom of 12 times our sample standard deviation of 210.626 divided by the square root of 13, which is our N value. And rounding off our answers to 1 decimal place then once you get that typed into the calculator.
$2269.9.
2269.9 is our lower limit. 2626.7 is our upper limit. And again, you can see that our mean, 2,448, would be between my 2 numbers. So that's a good sign. All right.